So today I've got Kent Marsh back because you see we had him on last week and you guys seem to like him, so we're gonna give him another chance. So Kent has a very long history in development of software, and he thinks he has some insights, and I think he does too, some insights into the whole world of digital Optimus. And of course, that's something we've been spending a lot of time on the last couple of weeks. I don't think we can spend too much time on it because, as some people have said over the last couple of weeks, it is three times as big a business as Optimus himself. So, if it's three times as big as Optimus, I think it requires us to get as much understanding as we possibly can. So, hello, Kent. Glad to have you back.
Yes, good to be back.
All right. So, give us a couple of more minutes on your background. You're a consultant, I understand.
Yeah, so I have been in the software business doing business application development uh, for all my whole adult life,
Yeah.
which is long at this point. So initially, I started out as a programmer, but moved up to architect, and I got involved as a consultant with some major consulting companies, and we went into corporate 500 companies and implemented very large enterprise solutions that were mission critical. So one area that I got into over time was the insurance area. So I've worked at companies like Progressive Auto Insurance. There was a $500 million project at Allstate to rewrite all of their
Wow.
insurance processing. I was
Yeah.
involved in that project. Um, and I also worked at Geico Insurance, actually a couple other insurance companies as well, but many other kinds of businesses. But ultimately, my my area of expertise is the implementation of enterprise applications.
Okay.
And
Right. Mhm.
typically in the past, they've been hosted on the cloud. And then the last couple of years, bringing in AI interoperability with those applications.
All right. And so you're talking about the interface part of this, so the ability for the user to easily address things, training of the user, et cetera. Is that what
Well, first off, I just wanted to understand what digital Optimus really was. And with any new technology, there's a lot of hype.
right?
And it reminded me of like when the internet first came out back in the 90s. There are a lot of people chasing after what they thought it might be able to do. And then the things that actually won were a lot different than
Right.
a lot of things. So I think we're in the same area with AI. I mean, it's a brand new technology. It's being rolled out. It's being adopted quickly in a lot of ways.
Yeah.
But how it's really going to be impactful, we might not know for a few more years to see how it really plays out. So that's kind of why I want to look at digital Optimus. I mean, it's one of these, here's a technology that people are putting a lot of hype into. And I wanted to know how real that was.
Yeah, and as I've been pointing out on the show a ton, and Jeff Lutz has been echoing, not echoing, actually just agreeing with me, is that we don't need to worry that this is going to be like that every single Fortune 500 company or every single mom and pop or any is going to all do this overnight. It will probably take 10 years, and 10 years from now, there will still be some companies out there that don't have any or almost no AI applications, much less the digital Optimus helping them out. That's just my experience as a consultant the last 18 years. All right. So, Kent, you've got a slideshow where you're going to give us a little more, a little bit of what you've learned and what your understanding is.
Yeah, let me see if I can get this thing going here. All right, so I put together a PowerPoint presentation just to kind of get things out there so we could see pictures and kind of get a sense of what things are. And I apologize that some of the text is small, but the content's there, and we might be able to put this up for people to read later. But the idea is to show how a digital Optimus could do the work of many office workers. How is that really going to work?
Mhm.
Okay, so let's kind of define some terms first. So we've heard the term macro hard, we've heard the term digital Optimus. In the Macrohard ecosystem, we have Grok, which is going to provide the brains. We have the digital Optimus, which is going to do the screen work. And I put these together in a box because these guys are going to work together a lot. Also in that ecosystem, and this is going to grow over time. And right now, there's probably not that many agents, but over time, there could be thousands or millions of agents that are AI agents running around doing specific kinds of tasks. And that could get rolled into some of this work as well.
Okay.
The idea of a sandbox execution environment, that's where you could build a system and run it in a sandbox so you're not affecting anything outside. It's just a test environment to make sure things are working correctly.
Okay.
So that's good for security reasons and just all kinds of reasons. The compute backbone, what is that? Well, you could consider everything that's doing computing part of that backbone. There's the systems that are running Grok. There's the AI4s that are running digital Optimus. There's the computers that are doing visual kinds of representations. Some of it's working on a client system, perhaps. Some of it's working inside the XAI environment. So it can incorporate quite a lot of things. And then as applications grow over time and it tries to do more and more things, I'm sure we're going to just, this computing backbone is where a lot of things are going to start branching off from. The deployment infrastructure, what is that? Well, in order for a customer to use Macrohard to process their applications, they're going to need to be able to call it, right?
Mm-hmm.
And so and a lot of this is undefined at this point, but I would gather that there's going to be some software that gets loaded onto a customer site so they could turn their applications onto Macrohard.
Okay.
It just makes sense to me, instead of digital Optimus trying to log into a system of, some proprietary software running in a network that's protected with all the password protections and things like that. Rather, turn that around. Let the customer host the software that calls the digital Optimus to do work for it.
Mm-hmm. Mm-hmm.
Also in that would be some management software to know who's using it, what's happening, how successful things are. You have problems, how do they get flagged, issues that you want to address. And there's just a lot of things. The telemetrics of using the system. I mean, on and on and on. So things that IT managers care about.
Okay.
Okay.
Got it. Got it. Yeah.
So what I did here is I'm moving your picture around. Does that move anything?
Everything's good. You're good.
All righty. So the diagram on the right-hand side is kind of like a process flow diagram of what happens with FSD.
Uh-huh.
So I'm not here to go into the weeds of how FSD really works. I'm trying to simplify this to almost a black box kind of a thing. So what goes into FSD? Well, the input is from the cameras. And I have a Model 3. It has 8 different cameras. And these cameras see what's around the car. It's 360-degree. And these cameras are operating and sending that information into there's what they call the ingestion and initial processing. So that's putting this stuff into a format that the neural network can deal with. Maybe there's some video brightness that it needs to deal with, or contrast, or I don't know. There's all kinds of things it could do. But it does some initial processing. And an interesting fact about this is that there's this continuous 5-second circular buffer. So what is that? Well, imagine 36 times a second, a video image comes in, and it builds up a 5-second buffer of history. And when a new image comes in, then a piece of image gets tossed off the back end. So you always have like the last 5 seconds. As time goes forward, I'm just keeping 5 seconds of whatever happened in the last 5 seconds. Okay?
Yep.
And now I have that for each of the cameras. So you have 8 cameras, you got 8 5-second buffers. Now that goes into the neural network. The neural network looks at these images and it tries to make sense of them. One of the first things it does, it figures out what the objects are in that image, right? So, oh, there's a car. There's a pedestrian. Here's the boundaries of the road. There's a building. It looks like a building. I don't care about buildings because they don't move. They don't hit me and I won't hit them. So it will make sense of the 3D environment that it's in and map that out inside its own little brain. So you could actually, and you've probably seen visualizations of like a 3D environment.
Right.
And so it does that from these 8 cameras. And it does it incredibly fast. And one of the things that's really special about the AI4 processor is Tesla's done a fantastic job of making this complicated process really fast. And it runs super efficiently with low power on a chip that's inside a car, right? This $650 chip.
Right.
It's an incredible technical achievement. Okay.
Yeah.
I don't think we appreciate that much, that enough. But, the Tesla's done a great job, and they're going to be doing even better job on AI 5 and 6.
Right.
It's just amazing what they're able to do. So kudos to them for that. So it does this 3D object representation. And now what does it do with that? Well, if you're on the road using FSD, you've seen that blue kind of thing showing you what your path is.
Sure.
So it understands your path. There's a plan. How do I go on that path? And if you've navigated to some place like navigate home, okay, it's figuring out how to get Randy Kirk home. And that path is part of the planning process. And it's going to figure out, okay, now based on this image that I see, what should I be doing here? I'll just stay in my lane. Or, oh, there's a red light I see ahead. I'm going to slow down. So based on its environment, it's going to make decisions about how to implement its plan. This is where the all the training of that model for FSD comes in. So there's just so much information that needs to be figured out, and the model breaks that all down into a way where it can see these pictures, see the 3D images, and with the 5 seconds of history, it can calculate how fast things are moving. Oh, there's a car coming toward me. I need to avoid it, right? So with that 5-second history, it can actually calculate the speed of what you're doing, the speed of the car coming at you. What can the car do to safely avoid that situation? Tremendous work. Okay, so another set of kudos to FSD to figuring out this fantastic model, using billions of dollars of computing power cranking against this stuff to create this model. So at the end, what happens? It comes out with signals to your steering wheel, to your pedals, maybe a turn signal. Not a large, just a handful of controls, really, when you think about it. So you have all this information being processed to figure out, do I turn my steering wheel left or right, fast, slow? Do I apply the brake? So these are control outputs. So in the simplest way to look at it, you get perception, what the cameras see, and the output is the action. Right. In the middle is this black box called FSD.
Right.
All right. Well, let's talk about digital Optimus. It's same old for the almost 100% here. You have pixels coming in and you have controls coming out. So let's look at what's coming in. Well, instead of a camera on your car looking at the world, what it's going to do is it's going to put a computer screen as input. So if I'm, let's say I'm an insurance company and I have an application that manages insurance claims, I have have an application for that. And the opening screen of the application might be something like, pick a claim to work on. Okay. So that first screen would come up and that would be the input. And just like the car, there's an ingestion and processing step where it's going to take that computer screen and put it into a format that the neural network knows how to deal with. Now, the neural network is going to have some software that it currently doesn't have. The neural network right now has the FSD software that tells it how to navigate around on a road.
Right.
What this software will do is tell it how to navigate around on a screen. And the difference in size, for me, when I download FSD, a new release, it takes about an hour to load on my car. And the estimate for this software is that it might take 3 to 5 minutes.
I see.
So my guess is that Tesla will just include that with the software releases. Just roll it in, whether you use it or not. It'll just become part of the software package.
Right.
So when you download an update, that gets updated as well. So what's in this software? It's software that knows how to look at a computer screen and break it up into components. And those components would be things like, I got a text box here, I got a label here, I got a title over here, I got a button, I got a radio button over here, okay? And so all those different elements, what in the software world we call those controls, if you're in on a web page, okay? So it breaks up what's on the screen as controls. And it's just what's visible. So, an issue that I can see with that would be like, well, what about a drop-down list box or something like that, a scroll bar, right? I don't know how they're going to solve that. You probably have to scroll to see everything in the list. But what this does is it takes all those controls, breaks them up, and puts them in a format that it can send off to Grok. So it says, okay, here's a screen. Here's all these fields and buttons. Here's the text that's inside all these things. What should I do? And it passes that off to Grok. So Grok is going to say, and this is going to be a call over the internet because you don't have Grok necessarily running on your car, right? So it makes a call to Grok and said, hey, Grok, I'm using this application from ABC Insurance, and this is the screen I'm on of this application, and these are all the values of the fields. So that's kind of like my prompt to Grok. And then Grok will say, oh, okay. I know that application. I know how to work on this. And it takes that information and then comes up with a plan on what to do. What you need to do here is fill in these text fields with these values, go over to this button that says submit and click it with your mouse. Something like that. So it will pass back information back to the AI4. So that passing back will start step number 5. Okay. So now what's it going to do? Now I know how I'm supposed to do what Grok asked me to do. I'm going to convert that into something that I can send back to the customer. I'm probably running a virtual desktop. Okay. And so all I really send back are keystrokes and mouse movements. Just like an end user communicating with an application, when they're sitting in front of a screen, their form of communication is keystrokes and mouse movements. That's it. So let's say it's a web page. They might say, put in these text values at these coordinates, and then move the mouse to this coordinate and hit click. So that's the kind of information that's going back. So again, in the simplest form, I have pixels coming in, and my action coming out is keystrokes and mouse movement.
Okay. All right.
So, so what about a user that wants to make money being a Tesla owner and using digital Optimus? Well, I've heard different amounts tossed around how much money they'll make, but here's what you need to be able to be in on this. First off, you need a Tesla that has an AI4 processor or newer. It doesn't work on AI3s.
Right.
You need to have charged batteries.
Okay.
I don't think they need to be fully charged, and I don't think you'll need to be plugged in.
Yeah.
But you need to have enough power to be running. And exactly how much power that is, I think that's going to be one of these things that Digital Optimus software would figure out. Oh, this guy's got 50% charge, 50% charge. I can do X amount of work with that. And maybe not let you go below 10%, something like that. That's not defined at this point, but that's kind of the rules I might see them doing. Now, if you have it plugged in, it'll just crank and crank and crank. If it's not plugged in, it'll based on how much energy you have in your batteries. And just to kind of understand how much of a draw that is, and when you put your car into Sentry mode, that's a draw on the power, but it's not as much draw. I mean, that's more draw than the Digital Optimus is likely to use. Okay, so that's a pretty good deal.
Yeah.
All right, so that's Wi-Fi connection. We're going to be doing a lot of conversing with Grok, lots of talk, a lot of chatter. So you need to have a Wi-Fi connection at least, right? Maybe you have a Starlink sitting on top of your car. I don't know.
There you go.
You need to be connected to the internet.
Yeah.
Okay. And what software do you need? And we talked about this earlier. I believe that they'll just load this down with your over-the-air FSD updates.
Sure.
So it'll just be part of your software package. And then probably there'll be something on your Tesla app running on your iPhone, let's say, where you can opt in or opt out. Say, hey, from 6 o'clock in the evening till 7 o'clock in the morning, hey, go ahead, use it. Something like that. So you might have a scheduled opt-in, opt-out. None of these are defined. I'm just kind of throwing that out. But I'm sure you as an owner will need to opt in and opt out.
Right.
Okay. So this is kind of interesting. I didn't, doing my research here, I kind of found out about this System 1 and System 2. There's a book out there by Daniel Kahneman. I'm pronouncing that. I would not want to be Daniel Kahneman. So I believe that's the pronunciation, Kahneman. And he wrote a book called Thinking Fast and Thinking Slow. Thinking Fast and Slow. And apparently Elon Musk had read this book. And that gave him the idea of a digital Optimus and how to architect it.
Wow.
So he's the architect of this approach, which is, I think, something to note.
Sure.
So they break it up into two systems, System 1 and System 2. Well, what is System 1? System 1 is, it's your fast, automatic, intuitive thinking. It's reactive, right? I see something, I do something. If you're doing some drudge kind of a job, you probably don't even think about what you're doing after a while, right? You're just doing it, right? And, people that do these repetitive jobs, they just kind of probably get into a mode where they're just cranking out things, not really thinking about anything, just going off of reactions. That's kind of like your System 1 way of thinking. System 2, this is your slow and deliberate, analytical kind of thinking. And you kind of have to stop and pause and really use your brain. So this is, and you got to focus, right? If you've ever done software programming or some other kind of work where you're trying to do something technically challenging, where you really need to focus, you want to get into that System 2 way of thinking, right? So that was kind of like the basis of how these two ways of thinking are defined. Now, how do we apply this? Well, in the Digital Optimus mode, think of System 1 as the AI4 chip. It works super fast. It can look at a screen full of objects, and it can pick them apart and find those objects, see where they are, keep track of the history for the last 5 seconds. It does all that processing super fast.
Mhm.
And when we apply that to digital Optimus, it's like, oh, here's a screen. Boom, I can take it apart, put all the pieces and organize them in a hurry. I don't have to think about it. Okay.
Yeah, yeah.
So that's what it does. It does all this parsing, um, and then it can generate the low-level signals that are given at the end. So it can crank those things out. It's not doing thinking. It's just reacting and input, output, input, output.
Mhm.
Okay. System 2. Now this is where Grok comes in. Grok is the big brain.
Yeah, yeah.
All right. So the coordination between system 1, system 2. System 1 says, boy, here's the playing field. Here's what we need, here's what everything's set up for. Now you as the brain figure out how we're going to deal with this. So Grok can analyze what's going on, understand the actual content of what's on the screen, and apply business rules and apply the kinds of things that you need to know about the application specifically. What policies do we use? How are different screens used? What other things do we need to do with this screen? If some error message pops up, what does that mean? How do I work around that? So all of the manuals for an application and the guidelines and the company policies and those kind of things are going to be available to Grok for that application. So he'll know how to deal with this screen. So that's the system 2. Okay.
Yep.
And there's some system 2 monitors, system 1, it can override it. How this actually works is this working together. I think we're going to learn a lot more about that over time. And it's probably going to evolve over time, like how these two systems work together. But that's the idea. I'm putting the processing where it can do it the best. So
Right.
the AI4 is super good at picking apart images, and system 2, the brain, is super good at logic.
Right. And yeah, go ahead.
Okay. So I wanted to break this up into a real world example, and we could start that now, or we could.
Sure. Let's go ahead.
Okay. So what is a real world example? I have this fake insurance company called ABC Insurance because I've been in the insurance area for a while. So I thought it'd be fun to just create a company like that. And they have hundreds of workers who process insurance claims. Now think about this. If I have a worker that I pay, let's say $75,000 a year, that's not a huge salary. But by the time you add Social Security and benefits and vacation time and personal days and all this other kind of stuff, you're probably actually, as a company owner, you're out $100,000 a year for that employee.
Absolutely.
So you've had this experience. I don't know if 25% is a good ballpark, but
it could be
depends.
a lot. It could be a lot more, but that's
it
fine.
could be 30%. It could be, depends. So I just use this as an example, just to get a ballpark. So I got $100,000 a year for a data entry worker that's costing the company. And how many hours of actual work do they do? So when they come to work, they have lunch breaks, they have potty breaks, they have coffee breaks, they have meetings, they have HR things. How much actual work time do they have? I don't know. It depends on the environment. It could be 6 to 7 hours a day. And there might be, peak periods where people stay longer, put in 10 to 12-hour days or something. And other days that are half days. Who knows? But I'm just trying to throw out an example.
Sure.
So if you average, about 6 to 7 hours a day, that's about 1,600 hours a year. And that works out to about $61 an hour.
Okay.
And let's say I do 10 claims an hour. So that's, 10 claims, I'm breaking an hour, and 60, I'm spending 6 minutes a claim. So that's $6 per claim
Right.
that it's costing the company to process that claim, do that work.
Mm-hmm.
All right. Plus, there's other overhead. Workers take space.
Right.
They need training. They need a place to work, a computer, a cubicle, a parking place, a bathroom, a break room, an exercise room,
Supervision,
maybe. I don't know.
supervision, hiring and firing. Yeah, I get it. Yep, yep, yep.
Yeah. So there's other overhead that I'm not really counting into this, but it's probably more than 100,000.
Yeah.
Okay. Now, what happens if we replace this worker with a digital Optimus? Digital Optimus can process that same insurance claim much faster.
Mm-hmm.
There's going to be some setup, and because this isn't actually out there yet. Elon said 6 months maybe,
Mm-hmm. Mm-hmm.
but being around large corporations with project teams and everything, they're going to want to, do some investigation, do some research, maybe do a pilot, do all these kinds of things. It might take them 6 weeks to 6 months.
Mm-hmm.
It depends on the organization, how fast they move. But it doesn't happen overnight. So they're going to take some time figuring out what to do. And because it's using an existing application, they're going to still use their IT software that's probably running in the cloud. So their application's running on some server in the cloud, and their database is probably in the cloud, near that same data center. They have network infrastructure, all this kind of stuff. So all that infrastructure is there today, and they're just going to leverage that to work with Digital Optimus. And I came out with, here's a sample cost of 50 cents per claim.
Right.
So I'm going from $6 to 50 cents a claim.
Yeah,
And I think you could even get that lower.
probably.
So, because, and I'll bring this up later too, but think about this, a single car that has 8 cameras, it's doing the video processing on 8 cameras simultaneously.
Yeah, yeah, yeah.
Well, it could actually run 3 to 6 screens simultaneously.
Yeah.
So it can do the work of 3 people or 6 people simultaneously much faster.
Right.
So one instance could be replacing, you do the math. I'm not a mathematician, but it's a lot of workers.
A lot of workers.
Okay. Not only that, workers tend to work 8 hours a day. This Optimus guy, he doesn't care. He can work 24/7 if he's sitting around doing nothing. So you're not constrained by the time of day. You might have, a lot of people using their cars during rush hour, beginning or ending of the day.
Right,
But
right.
by and large, you could work all night long,
Right.
constantly work over weekends. So the actual utilization of each car, I haven't tried to figure that out. But just the fact that you can have any car anywhere be working on stuff, you could crank out a lot of work very quickly, and it wouldn't take anywhere near the time that a lot of companies have to deal with something.
100%.
So they wouldn't have backlogs. There's also a lot of management and auditing data that go into Digital Optimus. So there's these reasoning tokens you've probably heard about.
Mhm.
So a reasoning token, it explains why it made certain decisions. So in a car, you might have, why did you change lanes?
Yeah, yeah, yeah.
Well, because the car in front of me was going too slow, so I moved over to this lane. Okay, so there's reason behind that, and these reasoning tokens are recorded as a log file, and it's been envisioned. I don't know if this will be true or not, but I think so. Is you could do like a replay, so I could have a visual replay of the session
Yeah.
Here's me using the screen, and here on the side is all this reasoning logic telling me why I did what I did.
Yep.
Okay, so Digital Optimus says here, I filled in these fields, I filled in these values, I clicked these buttons, and here's why I did each one of these steps. And so that becomes a nice audit log, and you could see a textual version of that. And once you have all that information, there's all kinds of things you can do with that. Okay, reduce training. I don't need to train Optimus how to use your software. He can read the manual himself.
Right.
Okay. Consistent level of work. That's something that people deal with, you know, different users are at different levels. You know, you have your power users, you have your, you know, people that are newbies. And so if you want a consistent level of work, the software tries to give you that, but that's always seems to be an issue. I also thought about multiple languages. I mean, you have, there's, you know, if you have forms that are done in Spanish or French or German or Chinese or whatever, Optimus doesn't care.
Right.
He's really good at languages. So you could be doing, you know, international kinds of businesses that are global, the forms for all these different things. So for example, I've dealt with systems where we build it in America, but the users are all over the world. So you have to do this translation kind of thing. It's really a pain. And the documentation that they might be associating with their claims, you know, here's a claim that's got a police report in Chinese.
Right. Right.
So all these kinds of things that you might need to deal with, it really lowers the costs.
Right.
And so, and then another thing I think about as a software builder, UX, that's a term for user experience. So when you think about, I'm designing software that's intuitive for a human being. Well, if I'm designing software for Digital Optimus, I might have a whole different way of looking at it.
Yeah.
So humans, you try to keep the amount of information on the screen not too overwhelming, right? Too much data on the screen. It's I can't deal with all this. You know, it's confusing me. So you end up with little tabs that open up and another tab that opens up, and another tab that opens up, right? And so you get these navigations where I drill down, up, up. So, but a Digital Optimist, maybe I could just lay the whole thing out for him. And here's a view of you know, 20 screens all at once.
Yeah, exactly.
I'm just throwing that out as a possibility.
No, yeah, definitely. Yeah.
So again, if you do that, the Digital Optimist could do that even faster.
Yeah.
So that's a whole new area, I think. You know, instead of human experience, it'll be digital experience. What's the digital experience for this? All right.
Okay, Kent. So we are up against a hard break right now, but Kent is going to be back over the weekend. I think we think we'll find a time, but we do have a part 2 to this. So Kent, going to thank you for your second time on the show, and we'll look forward to doing it again here in a little while. And any last words of wisdom to the folks that are out there?
Well, I hope at least this much. It helps people understand what Digital Optimus is and how it works.
Yeah.
It's not this giant mystery. And so now we're going to see a real world example. And I think that'll just make it even more clear and it give you a chance to think of questions to ask. And I'm happy to respond any way I can.
Yeah, put your comments below, and Kent says he'll check them out and give you some responses. Okay, we do have to go. Thanks, Kent, again for coming on, and to all of you out there, it's been great talking to you.